Hey everybody, this is Mr. Brooks, and I'm going to talk about the is it true task. Again, this is one of my favorite tasks because it allows you to kind of see what's going on and identify the mistake. And I love, more than we just do the problems, I love being able to explain it. So this is also goes back to vocabulary. So with Amy's going to go from 5 minus x equals 6 to x equals 6 minus 5, and it looks like she subtracted the 5 from both sides. And when she did that, she left off the minus sign. So that's a great way to say it. Another way you can say this is she rewrote the math sentence, and when she rewrote the math sentence, she rewrote it incorrectly. There's another way I was thinking of, but I can't remember it right now. But for Ben, if you take a number away from 5, the answer will be less than 5. This is totally what we teach kids year after year after year after year, all the way till we explore this crazy thing about negative numbers. If you have a number and you take stuff away, then you have to have less because you took stuff away. And so, Ben is correct, but Ben also has the misconception that there is negative numbers. Okay. And so, we know that there's one answer. Ben uses the words, it's never true, and that would be like a no solution problem. So maybe these kids are learning that there's problems where there's no solution. Or, maybe it's like it's like a math rule, like, you can't divide by 0. But the way to do this, the way a lot of you guys did this, was subtract 5 from both sides and then divide by -1. You get x equals -1. Down here, Amy says 8x and 6 are not like terms. That is correct. She is correct. Those are not like terms. If the equation was 8x minus 6x equals 2x, then it would always be true. That is also true. So Amy is correct. But there is a solution to this. I mean, what she's essentially saying is, like, I can't find a solution because they did it wrong. I mean, they're not like terms, so you can't do anything. And you can operate with like terms across the equal sign. You can subtract 8x from both sides. That would be the inverse operation. And you can subtract 2x from both sides. It's true, like 8x and 6 are not like terms, so you can't add or subtract those, but you can cancel off everything else and isolate the variable here. And then with Ben, it looks like what he did was he plugged in possible answers and he just checked. And this is what's called guess and check. Maybe you guys have heard guess and check before. It's a very valid way to solve things. And so we plugged numbers in, and he found that sometimes they don't work, and at least one time they did. So it doesn't work for all values of x, just for some. That is completely true. Now we know that it's only possible for there to be one solution, no solutions, or infinite solutions. So if it works for some solutions, then it has to be that there's one solution. And if it worked for all the solutions, it would be infinite solutions. So, Ben did not follow our inverse operations pathway, but guessing and checking is a real thing in math, and it's a very valid thing to do. It might be slow, but you can totally do it. So the way you guys did this is you would subtract 8x from both sides, or subtract 2x from both sides. I think subtracting 8x might be easier in this case. You'll get -6 equals -6x, and then that'll give you x equals 1. And you can see, when x equals 1, you get a true statement. So, okay, well, that is the task. And so, if you're listening to this, those are the vocab words I was trying to get at, and we were trying to find the misconception. So there you go.